All right, today we're going to look at transformations on two different parent functions. First of all, we're going to look at the linear parent function. Remember, the equation is just y equals x. The points that we like to use for this one, really you could use many different points, but we like to stick with the -2, -1, 0, 1, and 2. That makes our y also -2, -1, 0, 1, and 2. If I plot these, again, we're just going to have this straight line, or a linear equation that passes through the origin with a slope of 1. Our domain for this graph is going to be all real numbers. Our range is also all real numbers. For the absolute value function, remember we use the same x values. Here's your equation. And remember, when you take the absolute value of -2, you're going to get just 2. Absolute value of -1 is 1. 0, 1, and 2. When I plot these, the right side of the graph looks almost exactly, actually it does look exactly like the linear one, but on the left side, because you only have those positive outputs, you're going to have kind of a reflected version of the linear. Creates that V shape. So, remembering what we know about, one more, domain and range. What is the domain of this graph? All real numbers. Range, we only have those positive values right now. Y is greater than or equal to 0, or if you prefer, from 0 to infinity. Knowing what you know about transformations from quadratics and square roots, we should be able to identify already what's going to happen from each of these changes to our equation. So this is our linear function. If I add a 5 to the outside of this graph, this is going to move it up 5 units. So picture this line up here moved up 5 units. The next one, the +5 inside the parentheses, is going to, if you remember, inside is left or right, plus is going to go to the left. 5 units. If I take this line again, and instead of moving it up 5, I'm going to move it left 5. If you notice for the linear, there's actually no difference between moving it up 5 or left 5. You're still going to actually get the same graph. -2 in front, you should know from what you know about linear equations, that's going to affect your slope, but the negative reflects specifically over the x-axis. The 2 is going to be a vertical stretch. Again, if I take this line and I reflect it and then I stretch it vertically, you're going to have a steeper line. Similar things happen with the absolute value. If you put a 2 in front, that's still going to be a vertical stretch. Which again, picture this V stretched up, it's going to get skinnier. This one has multiple transformations on it. -5 inside the absolute value signs, that's going to be our left or our right. And a minus is going to go to right 5. +2 is going to go up 2. With the next one, 4 different types of transformations. The negative reflects, the 2 stretches, the 5 +5 inside, left 5, -2 outside, down 2. When you're graphing these, it's going to be important to pay attention to what type of function you have. Do you have a linear or do you have an absolute value? That's going to determine a lot about what the shape of your graph is going to be. Looking at this next equation, 3 transformations. The negative reflects, the 2 stretches, +3, up 3. So again, I'm going to draw my table of values over here. -2, -1, 0, 1, and 2. -2, -1, 0, 1, and 2. Remember, this -2 in front is going to multiply all of these numbers by a -2. When I do that, that makes my new y values a 4, a 2, 0, -2, -4. I like to use those to help me graph the rest of this. So up 3, I'm going to take my 0, 0 point, and I'm going to move it up 3. Put a dot. From there, remember your two choices, you can call that your new 0, 0 and plot your points from there, or you can continue to find your old points and just move each one of them up 3. I'm going to call this my new 0, 0. So if this is 0, 0, my next point, it looks like is at 1, negative 2. Then 2, negative 4. Negative 1, 2. Negative 2, 4. And there's my transformed graph. Again, domain and range, infinitely to the left and right, infinitely up and down, all real numbers. Doesn't matter how you move all real numbers around, still going to be all real numbers. Next one is an absolute value, I can tell because of these lines right here, has two transformations done to it. Minus 5 is going to go right 5, plus 2, up 2. So again, I'm going to go right 5, 1, 2, 3, 4, 5, up 2. That's my new 0, 0 point. Looking at the top of the page and my table of values for this, if I call this my new 0, 0, my next point is 1, 1, and 2, 2. On the negative side, it's negative 1, 1, negative 2, 2. Domain, still all real numbers. For our range, typically our range is y is greater than or equal to 0, but this graph has been moved up 2 units, which is going to shift my range up to a 2. Again, if you prefer, you could write your range like this using interval notation. Couple more examples. Here's another linear graph that's going to move right 2 and up 4. So again, my first point is 0, 0. If I go right 2 and up 4, I can put a dot. From there, I haven't reflected or stretched, so I know my next point is 1, 1, and 2, 2, negative 1, negative 1, and negative 2, negative 2. Domain, still all real numbers. Range, still all real numbers. Looking at our next example, back to an absolute value. This one has been reflected, stretched, and moved up 1. Again, I'm going to write down my original table of values. That's negative 2, negative 1, 0, 1, and 2, 2, 1, 0, 1, 2. The negative 2 in front, again, multiplies all of these numbers by a negative 2. When I do that, that gets a negative 4, negative 2, 0, negative 2, negative 4. So starting at 0, 0, I'm going to move my graph up 1 and then plot my new points. Next point it says is 1, negative 2. So if this is my 0, 0, I go 1, negative 2. If this is 0, 0, then it's 2, negative 4. Negative 1, negative 2, negative 2, negative 4. Notice our stretched absolute value graph. Domain, still all real numbers. Range, I've moved the graph up 1 and reflected it. So usually it's y is greater than or equal to 0. Because I've reflected it, y is going to be less than or equal to. Because I've moved it up 1, it's going to be 1. Again, you could use the interval notation, negative infinity to 1. Looking at writing an equation, again, you have to pay attention to this to tell you what type of graph to start with. This would like you to take an absolute value graph, go up 3 and left 4. Remember, left and right is inside, up and down is outside. So my equation is going to be y equals the absolute value of x. Left is a plus, so plus 4. Up is also a plus, plus 3. Next question. Start with a linear graph, reflect it, right 6, and down 2. So again, y equals negative for the reflection. Inside the parentheses, I need a minus 6 for the right 6. Close parentheses, down 2 is also a minus. Starting with the absolute value graph, reflect it. Stretch it by a factor of 3, left 4, and down 1. Lots of transformations here. So I start with y equals, reflection means negative. Stretch by 3 means a 3. Absolute value of x, left 4 goes inside, that's a plus 4, absolute value, down 1, minus 1. Looking at our next one, it's another absolute value graph. Shrink by a factor of 1/2 and go down 4. Y equals absolute value. I know to shrink it, that's outside and front, by a factor of 0.5, so I really needed a 0.5 here in front. Sorry, I had to squeeze that in. X. I'm not moving it to the left or to the right, so I can close my absolute value symbol and go down 4 is a minus 4 on the outside. 2 more examples. Starting with a linear graph, I'm going to stretch it by a factor of 2, right 3, and down 6. Y equals stretch of 2. Inside the parentheses, right is a minus 3. Down 6 is also a minus. One more. Again, linear graph, down 5, left 2. Y equals, inside the parentheses, I need an x. Left 2 is a plus 2, and down 5, minus 5. Great. 3 more examples. How do you find the equation from the graph? Well, luckily on the linear, they have specifically drawn the point. That's your new 0, 0. So if that's my new 0, 0, what has happened to this graph? It's moved down 2 units. Is that the only thing that's happened to this graph? Remember to check for stretches or shrinks. You have to count how far away that next point is. Usually it's 1, 1. This time our next point is 1, 2. That means this has been stretched by a factor of 2. What does that make my new equation? Again, this is a linear, so I know y is going to equal something with an x. The stretch goes first, so 2x down 2 is a minus 2. Now technically you could have put parentheses around the x, it's just really unnecessary, but if you want to emphasize the fact that the minus 2 is outside down 2, you can if you want to, it's just very unnecessary. This next one is an absolute value equation. Here's your new 0, 0, so it looks like we've moved to the right 1, 2, 3, 4, and down 3. So right 4 and down 3. Again, to check for that stretch, usually your point is 1, 1 away. This one again is 1 and 2, so it looks like it is stretched vertically by a factor of 2. So again, y is going to equal, I need a 2 for my stretch. I need my absolute value symbol so I know which type of graph it is, x. This one's moved right 4. Again, that's a minus 4. Close the absolute value. Down 3, minus 3. I should have boxed the first one. Last example, another absolute value sign. Here is your new 0, 0. Looks like it's moved right 1, 2, 3, 3 points. And down 2. Again, check for that stretch. Usually we're 1, 1 away. That's exactly how many, so there is no stretch here. All I need is my equation, absolute value of x to go right 3, that's a minus 3 inside the absolute value, down 2, minus 2.